Alright, welcome to Game Life. Today we are going to be looking at what? Electronic configuration. Now I'm going to be showing you in this video how to do what? Write electronic configuration. It's very simple. I'm going to show you a simple method and straightforward way in which we can do what? Write electronic configuration. So now the first thing you have to know about writing electronic configuration is what? This S, P, D and F. They are what? They are orbitals. Now, in each of these orbitals, the first one, which is what? S, accepts only 2 electrons. Now, the second one, which is P, accepts only 6 electrons. Now, the third one, which is what? D, accepts how many electrons? 10 electrons. And now, the final one, which is F, accepts how many electrons? 14 electrons. Now, with this is the first thing you have to know. Make sure you don't forget this. Now, aside from this, what else do we need? Okay, we're not focusing on this aspect now. So I'm just going to say it in case of those of you who doesn't know the shapes of each of these orbitals. The first one, which is S, is what? Spherical. P is what? Dumbbell in shape. D is what? Double dumbbell in shape. And F is what? Complex. I hope you get that in case of you don't know it before. Now, the next thing we have to move up is the kind of confusing part of this class. It's very simple. You don't have to cram the electronic configuration. You just know how to do it. And how do we do it? There is a table in which we are going to use in getting it. This table, you can easily know how to write it very, very fast. Anytime, even in the exam hall, you can draw the table and use it to what? Generate your electronic configuration. So now stay tuned. Now, for every atom, the first energy level, which is what? The first energy level has how many what? Orbitals? Only one orbital, which is S. So now we have 1s. And this 1s, because it's only S, we know that it's only 2 electrons, right? Now, this is the first energy level. The second energy level has S orbital and what? P what? Orbital. Okay, are we following? Now, the third energy level has what? S orbital, P orbital, and what? D orbital. Hope you see I'm following. You can draw this thing even when writing an exam. Very fast. It's not hard. Okay, now the fourth energy level has what? S orbital, has what? P orbital, has what? D orbital, and what? Has what? F orbitals. Okay, now on this now we've gone a bit far. Now with this information and this information, we can literally write any electron configuration we want to write of any atom or ion. Now this can go more than this. We can go to 5 energy level, 6 energy, 7th energy level. But basically most atoms or ions fall under this. So when necessary, you can write downwards. Okay, so now let's go. Now this is what I'm going to be using as my example, and now this is the one you are going to solve and drop the answer for me where at the comment section. So now let's go. For carbon, it's pretty easy. With this, how do we then use this? We don't use it like this. We don't follow this order. See what we follow. You have to do what? A stroke, and the stroke will just go like this. This is the first thing you write down. This is the second you write down. This is the third you write down. You get this sequence. And you feel me? Now, that is how you write it. Okay? What do I mean? If you want to interpret this for you, how do I mean you should write it? You have to write it like this. 1s. The next thing you write is what? 2s. The next thing you write is what? 2p. You have to follow the arrow. 3s is the next, right? Now, after 3s, what next will come back here, which is what? 3p. 4s, right? You don't have to grab it. 3d. The next thing is what? 4p. Now, the next thing is what? 4d. And what? 4f. Okay. Actually, if we went to 5, it wouldn't be like this, but since we stopped here, so this is how you're going to do it. You have to follow the arrow sequence. Okay, now let's pick an example, which is what? Carbon, right? Now this is an atom, not only an atom, is what? A non-metal. Now this element you are seeing here, what is this? This is what? Mass number. This is what? Atomic number, also known as proton number. Atomic number is also what? The proton number. So on this note, we don't have anything to do with the proton, neither with the mass number. The only thing we have to do is what? We need the number of electrons. And now there's one thing we have to know. In a neutral atom or element, a neutral atom element is not an ion, a neutral element. The number of protons is the same thing as the number of electrons. So if we have 10 protons, we also have what? 10 electrons. So now on that note, how are we going to write this? Now with this table we have here, we can do any electron configuration. So now let's go. Now since this is called the atomic number, also known as the proton number, we also know that this guy, since it's a neutral atom, is also the number of electron. So now let's go for the first energy level, which is S1. I'm going to write S1. In S1 we have 2 electrons. Since it can harbor 2 electrons, so now we just write 2 upwards. We still have how many? 4 electrons remaining if it is right. Okay, now the next thing we write is what? 2s, right? We say 2s. So now 2s, how many electrons is going to fall under? Is what? 2. How many is remaining? 2 is remaining. The next thing we are going to write is here what? 2p. Okay, so now for 2p, how many is remaining? 2 is remaining. So we can easily write 2. On this note, we have gotten the electronic configuration of what? Carbon. Count it: 1, 2, 4, and 6, right? So we've gotten the number of electrons. This is how to write it. Now let's go for the next one. The next one is magnesium, a metal. Okay, so now, and it's not carrying any charge. It's not an ion. It's not an ion, right? Since it's not carrying any charge, it's not an ion, so we can just follow the normal procedure in which we followed here. Okay, now it has how many protons? 12 protons, which means it also have 12 electrons. On that note, let's follow our procedure. Okay, so 1s has 2 electrons, right? Now the next thing we go is what? 2s. It can harbor how many? S orbitals can always harbor what? 2 electrons, right? For the p, the maximum for p is what? Why we stopped at 2? Because the electrons are finished, you remember. So now the maximum for p is what? 6. That's why I wrote it first. Okay, so now 2p now will now be what? 6. On this note, we already have 10, so remaining 2, right? So the next thing we just have to do is what? The following. The next thing in this array is what? 3s. On that note, we will just write the remaining 2 electrons. So 2 plus 2, 4, 4 plus 6, 10, plus this 12. It's complete. This is the electronic configuration of magnesium. Okay, now finally, the next thing we have to look into now is what? Calcium. But this is not a normal calcium. This was the calcium ion. And now pay attention. We have what we call a cation and an anion. Okay, now where should I write this in a very clear way? Okay, I should write it here. Now, cation and anion. Now, cations are what? Positively charged. They are what? Positively charged. Okay? Anion is what? Negatively charged. Okay. Now with this information, we can always know that what? Now, this thing confuses a lot of people. Now when you see +2, it seems to you that it kind of feels like what? It feels like what? This thing should be, we are adding more electrons, right? But no, if it's +2, it means the atom here is short of how many electrons? 2 electrons. Now let me explain how it will be very clear for you not to ever forget this. Now let's say we are doing what? We have 2 groups of 5 people. Now for example, If the other 5 are what? Green in color, they are what? Called the positively charged. And on my own side, we are what? Red in color, we are negatively charged. Now, for example, if from my own group we are 5, but from my own group 2 people fell off and they left my own group, we are remaining 3, and the other people are still remaining 5. And you know, we are trying to pull a rope. Obviously, the other people will start pulling us because they are more in number. That is why the atom is positively charged. If we calculate all of us together, when the other 2 has not left from my own group, we will be what? We are neutral. Do you get it? We are pulling the rope. Nobody is falling. But immediately 2 people left my own group, what happened? Obviously, we reduce, and the other people started pulling us to themselves. On that note, the whole body becomes what? Positively charged, because the positively charged side is now more, and the negatively charged is now less. So do you understand? That is why it's positively charged, because the negatively charged side is now less. So obviously the positive side dominates, which is why it's what? +2, meaning that the other side, the electrons are losing 2. Do you understand? I believe you guys understand. And those of you who really understood this better because of this video, make sure you state that in the comment section. Okay? Now, on that note, the way we write this guy, we are going to write this word. And note, positively charged is what? Cations. Which means this calcium is a cation. Now, this chlorine is what? An anion. So now, the way we are going to write the electronic configuration of this guy is not the way we are going to write these other guys here. So now pay attention. Now, first of all, if you are writing an electronic configuration of something like this, first ignore the charge. Behave as if you didn't know that charge was there. Just write the normal electronic configuration, which is what? 20 electrons, right? Number of protons is equal to number of electrons. So now let's go. Now, 1s, right? 2 electrons, 2s, 2 electrons, 2p, 6 electrons. We already have 10. We need what? How many more? 10 more. Now we have 3s, which is 2, maximum of 2 electrons. The next thing we are going to have is what? 3p, right? So our 3p, maximum of what? 6. Still is not yet complete. The next thing is what? 4s. 4s. Now, I believe it's complete. 2 plus 2, 4, plus 6, 10. 2 plus 2, 4, plus this is 10, which is what? 20 all together. We've gotten the normal electronic configuration of calcium. But now, it has a charge, and +2 means that it's short of how many electrons? 2 electrons. Now, where are we going to deduct from? Should we deduct from here? Should we deduct from here? Should we deduct from here? No, we are going to deduct from this one, the S, the highest energy level. The electron has to leave from the highest energy level. Now, pay attention. We are lucky enough that this electronic configuration ended with S. So, in case you see you are trying to write something like let's say which example are we going to use? Let me say aluminium or iron. And you found out that it ended with P. It ended with what? The P orbital. And there's the S like before it. Please always remove your electron from the highest energy level, which is the S. Don't remove from P. If you remove from P, it means you are wrong. Take note, you are wrong. So we are lucky enough that it ended with S. So we just have to do what? Remove the 2 electrons. You will write it 0. That's how you write it. Instead of you to remove it totally, write it. Then cancel the electrons later. If this S was here and P ended, remember you have to do what? Remove your electrons from the S because it's the highest energy level. The P is not the highest, it's a degenerate orbital. Take note of this, it might come in handy. Maybe when you are doing these exercises, you might experience it so that you don't go and just, like for example, maybe this guy was an ion and he ended with P. You are not trying to remove the electron from the P. It's wrong. This way you are supposed to remove it from the S. Take note of that, okay? So now let's go to the final example for today, which is what our chlorine what ion, which is an anion, is negatively charged. Why is it negatively charged? It's negatively charged because the normal on the neutral chlorine, the number of proton is equal to the number of electron, right? 17 proton, 17 electron. But in this chlorine, something happened. Our number of what? Remember, our number of what? Protons reduced by one proton left. So now the electrons now have more energy to fight against that because they are now lesser in number. Remember something, metals like to what? Give out electron, and what these guys non-metals like to what? Accept. Don't ever forget this, okay? So now on that note, let's go. Okay, what do we do now? Let's write the normal configuration. Now we have 17 electrons, so we are going for 17 electrons, right? So now let's write the normal one. S1, 1s, 2 electrons, 2s, 2 electrons, right? 2p, 6. We already have 10, remaining 7. So now the next thing is what? 3s2 is still remaining. Let's go. 3p what? How many now? We already have 12. So how many is remaining? We need 5, right? Yes. Let's count. This is what? 2 plus 2, 4 plus 6 what? 10. 15, 16, 17. So it's complete. On that note, what do we do? We've gotten the original configuration. For a negatively charged chlorine, which is an anion, remember in this aspect, what did we do? We remove electrons because what? It is lacking electrons by 2, right? Here now, it is no longer lacking electrons because the proton reduced and the electrons are much in number. That is why it's negatively charged, which means we have to add 1 electron. On that note, where are we going to add it? It is not like this guy that we had to look for what? The highest energy level. We can just add it from where we stopped, which is the P. We can add it to be what? 6. Do you understand? I believe by this time you must have understand that writing electronic configuration is very, very simple. Now, these are your exercises in which you are going to take down for me and drop the answer what? On the comment section. Make sure after watching this video, if you feel this video was very helpful for you in writing electronic configuration, make sure you give us a like, drop your comment, drop your answers, and what? Please subscribe. And don't forget, there is more to gain than to lose, so make sure you subscribe. That's not all. Your sweet drop is always in the end of the video. Thank you for watching.
God have mercy upon us.